Welcome everyone to the first of our Kent County Master Gardener Summer of 2021 workshops. My name is Debbie Nicole, and in addition to being an avid organic vegetable gardener, I am also the chairperson of our workshop committee and the organizer of these online events. I decided to offer this workshop after our Vegetable 101 series because there were a lot of questions about growing vegetables organically. Additionally, we have seen a lot of confusion when it comes to interpreting your soil test report. I hope to bring it all together for you today. In this workshop, we will look at the soil test report section by section, and we will talk about making organic choices to adjust your soil pH, fertilize, and add organic matter to improve the soil in your vegetable garden. Let's talk about soil. Soil has four parts: air, water, minerals, and organic matter. The mineral part comes from rock that has been broken down into smaller and smaller particles through the forces of nature and time. The organic part comes from the decomposition of plant and animal tissues and byproducts, such as manure. Did you know that every state has a state soil? We're going to talk here about the Delaware state soil, but if you live in another state, you can find your state soil at www.nrcs.gov, the Natural Resources Conservation Service at the U.S. Department of Agriculture. The link will be provided in your follow-up materials. Delaware soils are in the Greenwich series. This is a type of silty soil, which is fine sand, clay, or other material carried by running water and deposited as a sediment, found on the coastal plain of Delaware and adjacent states, as you can see from the map. The Greenwich soil profile is described by its four layers. The surface layer is brown loam. The upper subsoil is strong brown loam. The lower subsoil is yellowish brown sandy loam. And the substratum is yellowish-brown coarse sand stratified with dark yellowish-brown loamy sand. Of course, if you live in a development, the developers may have removed the original soil and replaced it with something not quite as nice for growing. Or you may have purchased soil to fill a raised bed. This is why it's so important to have your soil tested. Let's talk organic. There is a difference between getting USDA certification, usually for commercial purposes, and having an organic vegetable garden in your own backyard. To be certified organic, you must grow your crops according to federal USDA guidelines. Use only USDA-approved fertilizers and approved methods for pest and weed control. You must also certify that your soil has not had any prohibited substances applied for 3 years prior to harvest. What organic means to the home gardener generally is that you use organic or carbon-based fertilizers and plant-based pesticides such as neem oil or pyrethrum from the pyrethrum daisy, if you use them at all. Organic seeds are harvested from organic plants. Organic plants are raised without the use of inorganic or synthetic fertilizers or pesticides. Organic soils haven't been chemically treated, and organic amendments like compost can be added. U.S. soils have become degraded by unsustainable practices. Organic farmers and gardeners can help stop soil health degradation and even restore soil health by replenishing soil organic carbon and preserving the biodiversity found in soil. Here's a sample copy of a University of Delaware soil test report. This is not mine. University of Delaware uses a test called Malick 3. Other states or independent soil test labs may use a different test. This test is called a comprehensive routine fertility test. You can get a soil test for lawns, vegetable gardens, blueberries, or other special crops. So it's important to indicate on the soil test form where your soil sample came from, as the recommendations are different depending on what's growing in the soil. Today we are focusing on vegetable garden soil tests. We will talk about pH, fertility index values for the most important nutrients for your plants: phosphorus, potassium, magnesium, and calcium. We'll also cover other plant available nutrients: boron, manganese, zinc, and sulfur. Then we will touch on the rest: percent organic matter, buffer pH, percent phosphorus saturation, cation exchange capacity, and percent base saturation. Finally, we will look at the recommendations for fertilizers in the suggested fertilizer program at the bottom of the report and talk about organic alternatives. As you can see from the chart here, lower pH values are more acidic and higher pH values are more basic or alkaline. Both extremes are very harsh, as you can see from the chart. Pure water with a pH of 7 is perfectly neutral, but we can consider the neutral range to be from about 6.5 to 7.5. The optimum range for growing most vegetable crops is 5.8 to 6.5. Delaware soils tend to be more acidic, requiring lime to raise the pH into the target range. Soil pH is important because in soil that is too acidic, phosphorus, calcium, and magnesium become less available to plants. Soil that is too alkaline can become deficient in manganese and zinc. This chart shows the preferred soil pH for some common vegetables, sorted from the lowest, those that prefer the more acidic soil, to the highest, those that prefer more alkaline soil. Most of this information came from our Vegetables 101 series presentations, where we visited a different vegetable every week and we talked about pH at that time. You don't need to write this down. This chart is included in your follow-up materials. Natural soil pH depends on the type of rock from which the soil was formed. In addition, climate, vegetation, topography, and time tend to lower the soil pH. We should be aiming for that optimum pH range of 5.8 to 6.5, or a little bit higher or lower depending on the crop you're growing. If the pH on your soil test report is not in the optimum range, you may see a recommendation to add either sulfur to lower the pH or lime to raise the pH. If you are on the high side of the optimum range, you can add crushed sulfur to lower the pH. I do this for my blueberry plants. If your soil is too acidic or on the low side of the optimum range, you can add lime. There are two types of lime: calcitic limestone, which will also increase your calcium index, and dolomite, which will increase your magnesium. Adding lime can cause future soil tests to reach the excessive range for calcium or magnesium, but this won't harm your plants. It just means you don't need to add more. If your soil is high in organic matter, it will be more resistant to change in pH, and it may take longer or require higher application rates. The University of Delaware Soil Test Lab will look at your organic matter percentage in combination with your pH to make recommendations. Adding calcium-rich organic substances like clamshells, oyster shells, wood ashes, and gypsum, which is calcium sulfate, can also be used to raise the soil pH. Fertilizers are like vitamin pills for your plants. Nitrogen, phosphorus, and potassium are the most important nutrients for growing, which is why most fertilizers list the NPK values on their packaging. The three numbers indicate the percentage of each nutrient in the fertilizer. For example, a fertilizer with 5-10-10 on the label means that the fertilizer is 5% nitrogen, 10% phosphorus, and 10% potassium. An incomplete fertilizer will have 1 or 2 zeros. For example, bone meal has an NPK of 4-2-0, indicating there is no potassium in this fertilizer. So what do these nutrients do for your plants? Well, nitrogen is the most important nutrient for green leafy plant growth, but there is no reliable way to test for nitrogen at this time, which is why nitrogen is not included on your soil test report. With phosphorus, a lack of phosphorus in the soil causes your plants to have stunted roots and tops. Phosphorus is important for photosynthesis, cell functions, and flower and seed production. Most Delaware soils have sufficient phosphorus, and phosphorus-containing fertilizers are usually not needed. And last but not least, potassium. Why do we use the letter K for potassium? Well, P is already taken by phosphorus, so K is used because it's from an old Latin word kalium, which means potash or pot ashes, a good source of potassium. A lack of potassium in your soil causes poor stem growth, reduced quality, and poor yields. All organic fertilizers are derived from living things or naturally occurring minerals. They tend to have lower percentages of NPK and release nutrients slowly. While chemical or synthetic fertilizers dissolve quickly in water, organic fertilizers are broken down by soil bacteria. Since they are slow release, they are highly unlikely to burn your plants or form a crust on the soil. Organic fertilizers also help to make soil more water permeable, add structure, and make it easier to work and feed the beneficial microbes. Be aware that since the fertilizers listed here are all organic, purchased fertilizers can vary in their NPK values, so always check the label. The fertilizers shown in red in the chart are the ones I use in my own garden, in addition to homemade compost. According to my soil test, I don't need to add phosphorus, so I choose fertilizers with as low of a p-value as I can find. A word about compost. If you make your own, yours could be completely different from mine, so these figures are just an estimate. A word about green sand. What is green sand? Green sand is a natural mineral harvested from the ocean floor. It helps loosen soil, improve soil retention, soften hard water, and increase root growth. Note, if your soil test recommendation says you need to add potash to raise potassium, muriate of potash is not for organic gardens, but sulfate of potash is fine. So what happens if you add too much fertilizer to your garden? Well, first of all, you waste a lot of money on fertilizer. If your soil test results show excessive levels of potassium, phosphorus, magnesium, or calcium, the only thing you can do is not add more and let time take care of it. If your soil test shows optimum, all is well and you don't need to add fertilizer. Phosphorus is the nutrient that can really cause problems, not for your plants. They will only take up what they need from the soil, but for the environment, especially water. When you feed plants more than they need, especially with quick release, high NPK synthetic fertilizers, the excess can run off with rainfall or irrigation and end up in our streams, ponds, and lakes. Excess phosphorus in the water causes eutrophication, or an overgrowth of algae and other aquatic plants. This can result in algal blooms, surface scums, foul odors, impeded water flow, and ultimately the death of fish due to lack of oxygen. Some algal blooms can be harmful to people too, as they produce elevated levels of toxins and bacterial growth, causing people to get sick if they come into contact with polluted water or eat tainted fish or shellfish. These micronutrients in your soil are measured in pounds per acre units on your soil test. There are no specific recommendations given, but if the soil test lab determines a deficiency, they will include additional recommendations in the suggested fertilizer program section of the soil test report. Okay, magnesium and calcium. These nutrients are usually supplied by adding lime, dolomite, or calcitic, but eggshells, oyster, and gypsum can also be used to add calcium, while magnesium sulfate, which is also known as Epsom salts, can be used to increase magnesium. Deficiencies cause reduced crop quality, poor yields, and calcium deficiency can lead to blossom end rot in fruiting vegetables like tomatoes, peppers, and cucurbits. Boron. Crops with high boron requirements include broccoli, cauliflower, cabbage, rutabaga, turnips, beets, Swiss chard, and spinach. If your soil is boron deficient, you can amend it using borax or boric acid, but excess amounts can be toxic to some crops like beans and peas. Manganese and zinc. Deficiencies of these nutrients are rare, but you may need to add them in sandy soils with a higher pH. Manganese can be deficient in overlyme soil and soil with high organic matter content. Zinc deficiencies can happen in corn with high pH sandy soil. Sulfur. Sulfur is usually sufficient in the subsoil but may need to be added to surface soils. Sulfate is the form of sulfur that plants can use. And the rest. Don't worry about this unless you're a real chemistry science geek like me. This is the information that's used by the soil test lab to give you recommendations as to the quantity of nutrients to add. So briefly, I'm going to go through these. The buffer pH, the soil acidity that is neutralized by lime to raise the pH. This determines the amount of lime to be added. The higher the value, and 8 is the highest number you can get, the less lime is needed to reach the target pH. Percent phosphorus saturation. This value assesses the risk of phosphorus losses from soil to water or surface runoff. Less than 25 is a low to medium risk. 25 to 50 is a high risk, and over 50 is a very high risk that you will lose phosphorus to runoff. CEC, also known as cation exchange capacity. This is related to the soil texture, whether it's sand, silt, or clay. Higher than 20 means a higher water holding capacity, clay, organic matter, and available nutrients. Less than 12 means it requires more nitrogen and potassium. And percent base saturation, this is just the percent of the cation exchange capacity that is occupied by some of the nutrients like calcium, magnesium, potassium, hydrogen, sodium, and it predicts the nutrient availability to plants. As you can see from the graphic, nitrogen is continuously cycled and recycled through the ecosystem as a gas into ammonia dissolved in water, which is the NH4 ion, and nitrates, the NO3 ions. The nitrogen present in organic materials must be decomposed by microorganisms in the soil before it can be used by plants. There is no nitrogen content listed on your soil test report. However, if you indicated on your soil test form that your sample is from a vegetable garden, the report will recommend adding a nitrogen fertilizer to your soil prior to planting and later as a side dressing. The fertilizers recommended are ammonium nitrate, which is not commonly used anymore, or urea, whose use is widespread. We'll talk more about urea in a minute. These fertilizers in their commercially produced forms are synthetic, not organic, so we will look at organic options in a minute. Keep in mind that during the growing season, green leafy vegetables may benefit from a nitrogen side dressing, but fruiting vegetables with excess nitrogen fertilizer can have too much green leafy growth and produce less blooms and fruits. Root crops should not be side dressed because too much nitrogen will reduce yields and lower quality. Manufactured urea is a common nitrogen fertilizer with an NPK of 4600. It's cheap, easy to transport and store since it's sold as a solid in granular form. If you use urea, it should be immediately irrigated into the soil because if it's left on the soil's surface, it can release ammonia gas, NH3, which can be toxic to germinating seeds. Natural urea is in the liver of all mammals and some fish, and is found in blood, sweat, and tears, milk, and urine. Natural urea has the same chemical composition as synthetic urea. If you'd prefer to use more organic methods to add nitrogen to your soil, you have several options. First, use an organic fertilizer such as blood meal, feather meal, or fish emulsion. Or you can add fully composted cow, horse, chicken, or goat manure. But if not properly composted, manure can burn your crops, so be careful. And beware of seeds in the manure that might germinate in your garden. Another thing you can do, grow and then turn under legume cover crops, green manure, like clover, hairy vetch, field peas, or alfalfa. As a bonus, this process also adds organic matter. You can also plant nitrogen-fixing plants in the same soil. Some native choices are black locust trees, redbud trees, and American bayberry. Also known as acnerizal plants, they can take nitrogen from the air and with the nitrogen-fixing bacteria Frankia, form root nodules that provide a plant-usable form of nitrogen to the parent plants and others nearby. And then urine. As a natural form of urea, it can be diluted 1 part urine to 10 parts water and applied to the soil to add nitrogen. This practice is very common in developing countries and it's free. Let's talk organic matter. For the percent organic matter section of your soil test results, there is not a specific target range for organic matter. Northern Delaware soils have a higher percentage, while sandy southern Delaware soil has less. Generally, lawns only require about 3% organic matter, while vegetable gardens like 4 to 6% or even higher. It is also possible to have too much organic matter in the soil. Soils at 12 to 15% organic matter can hold too much water and become soggy. Some of the benefits of soil organic matter include organic matter provides essential nutrients, NPK, as it decomposes. Organic matter provides a habitat for soil organisms that fight plant pests and diseases. Organic matter helps plant roots spread through the soil more easily. Organic matter holds water in sandy soils and helps with drainage in clay soils. Organic matter provides holding places for nutrients. This is that cation exchange capacity. Compost is a great source of organic matter in addition to composted manure, decomposing leaves, and untreated grass clippings. So what will you aim to see on your next soil test report? Your focus should be on adjusting pH and making sure your primary nutrients are headed into the optimum range. These are given as fertility index values where 0 to 25 is low, requiring the addition of nutrients. 26 to 50 is medium, which may be adequate but better to increase to the optimum range. 50 to 100 is optimum, and the addition of nutrients is rarely recommended. And more than 100 is excessive, and no fertilizer containing the excessive nutrients should be added, as this will have negative effects on water quality through erosion and runoff. If your soil is deficient in any of the micronutrients, boron, manganese, zinc, or sulfur, this will be indicated in a note in the suggested fertilizer program on the soil test report. For organic matter, you should add more next fall, winter, or early spring before planting if your percent organic matter is less than 4. But if it's more than 12%, do not add more. Just give what's there time to further decompose. The maximum buffer pH is 8, which means if it's close to this number, you do not need to add lime. The lower the number, the more lime you will need to raise the target pH. You should try to keep your percent phosphorus saturation under 25 to avoid runoff into the waterways. Thank you for coming. You will receive links to these resources and more in your follow-up email. Cooperative Extension of the University of Delaware and Delaware State University is an equal opportunity provider of our services to the public. This is the end of the presentation. Thank you.